Welcome back to Clean Code and Programming Principles, the Ultimate Beginner's Guide. I'm Spiros from Programming Duck, and in this video we're going to cover the KISS principle, which stands for Keep It Simple Stupid, and the principle of least astonishment. Okay, so just like the previous principle, be pragmatic, these are also two principles that apply to pretty much everything in life, not just in programming. And of course they're equally important in programming, and they're extremely important principles. So KISS, Keep It Simple Stupid, just means to keep your code basically as simple as you reasonably can. You don't have to go too crazy, as we said before, with a pragmatic principle, but in general, it should be as simple as possible within reason. And the principle of least astonishment means that things should work exactly as someone would expect them to. And the same, of course, applies to your code. Your code should work exactly as someone would expect it to. It shouldn't do unexpected things. So these two principles are very important for reasons like these on this slide. As we saw in our human limitations a few videos ago, we need things to be simple and we need things to be understandable, because if they're not, right, we might, well, first of all, they're going to take us longer to understand how things work, and that's just a waste of time. If we can avoid that, then we shouldn't do that. Secondly, even if we spend a long amount of time reading the code in question, we still may not understand how it works. If it's complicated enough, we might just not get it, So obviously that's a situation we want to avoid as well. And finally, we might actually misunderstand how the code works. So maybe because we're rushing, or maybe because it's quite complicated and we just don't fully understand how it works, we might think that it works differently to how it actually does. And that's really bad because, well, say we're working on a function A, which calls function B, and function B does something different to what we think it does, right? So we work on function A, we modify it, we do whatever we do, or maybe we have to create function A from scratch. Maybe it's not there already. We call function B, and what we want code A to do is different to what it does because we misunderstand how function B works. And of course, when something works differently to how you intended to, that is by definition a bug. So for all of these reasons, we need to keep our code as simple as possible, and we need to make sure it works as expected at all times. Okay, so how do we apply these principles? And there are a few guidelines for them. And one of the first ones is always default to writing dumb code, okay? So what that means is that your code should be simple and how it works should be obvious. Your code should not be clever, okay? Someone shouldn't be reading your code and thinking, oh, that's pretty clever, okay? Because that's not how it works. How it works is, for code to be clever, it means that tomorrow the person that reads it, the process is going to go something like this. They're going to read the code for a minute. Oh, what does this do? Oh, what does that do? Oh, okay, this line. Oh, that's quite clever. I see what he's doing there, or what she's doing there. But that's how clever code works. You need to get the insight into how it works, and then you understand it. Does that make sense? It's clever because of that insight, or at least most of the time it works like that. So that is not something that we want. We don't want people to be reading the code for 2 minutes and then a minute later they think, oh, that's how it works. No. For all the reasons we said, right? Instead, the code should be as simple as possible. It should be obvious. It should be dumb. It should not be clever, because dumb code is simple and clever code is generally not simple. So that's one guideline. And another one is keep code short. In general, you want to keep code short because let's just say that if you have a 100-line long function, well, that is not a simple function to read and work with. But if you have a 10-line function, that has a much higher chance of being simple and easy to work with. So, pretty common sense stuff here. Another one, a really important one, is to use good names. And the benefit of this one is significant, okay? Because just consider this scenario. So if you have a function that you're reading because you want to see the details of what it does, and this function calls 3 other functions. Now, if those functions that it calls have good names that describe what they do, then you understand what they do immediately. You don't have to go to those other functions and read through their function bodies. You can just read the line, print 5 to the screen, and you know what it does. Or you can read the line, double every element of the array. Obviously, you wouldn't call it that, but I hope you get the idea. And you understand what it does. You don't need to find those functions in your source code and read them, and so on. But if they weren't using good names, that's what you would have to do. You would have to go through every function, and then those functions may have additional function calls. And you get a chain reaction of function calls. And basically, let's just say everything takes a lot longer to understand under that scenario. So use good names, you avoid all of that, okay? So next one is always consider the programmer reading the code for the first time in the future. And this might be a colleague that's brand new to the company, or it might be someone that just never worked in that area of the code base before, or it could actually be you 6 months from now or 1 year from now coming back and reading this code again because you need to work on it. And those people won't have any context into what's going on in this code. And one other thing to realize in relation to this is that when you write the code, this is kind of like how the process goes. First, you think, okay, I need this code to do X and Y. So you know what you're trying to do, and then you write the code to do that. Okay. But the new person looking at this code for the first time, they don't do either of those things. One, they don't know what the code is trying to do, because that's really what they're trying to understand here. They don't care about the implementation details of this function. They care about what it does, what it's trying to do. So they don't know what it's trying to do. And two, they also have to decipher your complicated code. So it's twice as hard, because you know what you're trying to do, and then you write the code. That's pretty easy. But understanding what the code is trying to do when you can't understand the code is not easy. That's quite a subtle point to understand, but I hope that makes sense. So anyway, the point is that the new person reading the code will find it a lot more difficult to understand than you do, who is writing the code. So what you have to do is write the code as simple as possible and think from their point of view, the new guys or girls' point of view. Will they understand this code? Make it as dumb and as simple and as obvious as possible. So the next point is consider immutability. And immutability means that once you define a variable, to never change the value of that variable again. So basically use constants as much as possible and do not change the values of things. And that's quite useful for a few reasons, but just consider this. If you have a variable that's a normal variable, the value can change. We're going to use an extreme example here, and consider you have a 3,000 lines long file. Okay, so you have a file that's 3,000 lines long. And on line 2,900, you're using that variable in something, like maybe a function call. Now, you don't know what the value of that variable is, because, you defined it on line 5, and its value was 29 at that point, but it could have changed 1,000 times until then, right? And when you changed it, you might not have just said, okay, like variable equals 20. So if that was on line 2,800, that's easy. You can read it and see it. But instead you might have done something weird, like variable equals variable times 2. And you might have had 100 of those calls in that file. The point is, you do not know what the value of that variable is unless you scan through 3,000 lines of code to see if it could have changed at any point in that file. So, that's ridiculous. You don't want that at all. So the easy and obvious way to avoid that is to just use constants. Because if something is a constant, then you know it cannot change. And on line 3000, you know what it is. It's what it was when you defined it. So it makes code extremely better and easier to understand if you do that. Now again, remember to be pragmatic. You don't have to use this all the time, but now you understand the benefit of it, so hopefully you can use it in your code and use it most of the time. Unless you have a good reason not to use a constant, then default to using constants, right? And the last point is to follow existing conventions. So for example, if the library that you're working with, or the framework, or your language have certain conventions, then use them. Conventions are good because if a new programmer comes into the team, then they can expect those conventions to be there, and it means that they can understand the code faster and easier. And not just that, but if you don't use a convention, then that same new programmer that came into the team, they may expect the code to follow a particular convention, they may expect it to do a particular thing in certain times, but because it doesn't follow that convention, it actually doesn't do what they expect. So now the code works differently to how they think it works, and of course that's the source of multiple bugs. So yeah, follow conventions wherever possible. And it's fine also, in fact it's probably good, if your own team has their own conventions in the code base. So yeah, feel free to set those up as well and follow them. Okay, so that's it for this video. I hope it was useful to you. I hope it made sense. So if you like this video, then please leave a like down below. And if you want to be notified of the next videos in this series as they're uploaded, then please click on the subscribe button. It really helps the channel when you do those things. And if you have any comments or any counter arguments to this video, then please leave a comment in the comments below. All right, thanks very much, and see you on the next one.